Hello, everybody. This is Keith Peterson and Matthias Stengel. I'm the product manager for our eCognition software here at Trimble, and Matthias is our technical support engineer. Hope you are all able to hear me and see my screen. If you are having any troubles, please write into our question or chat window, and you will get a response from one of our technicians on how to fix this. First of all, thank you for taking the time out of your busy morning, afternoon, or evening to attend our webinar. Today's webinar is looking at using eCognition for natural disaster mapping, in particular a fast prototyping test we did revolving around the Hurricane Harvey disaster that hit Houston earlier this year. So just again, who's going to be presenting here today. Again, my name is Keith Peterson. I'm the product manager of eCognition. I'm originally from the United States. Extensive background in geoinformation, the geosector. I've been working in the industry for over 10 years now, and over 5 of that has been with eCognition. I will let Matthias introduce himself later on when he comes in to show some of the work we were doing in Hurricane Harvey, but he's originally from here in Germany, also has a Master of Science degree in applied geoinformatics, and has been working with remote sensing data and eCognition for over 5 years. So between the two of us, quite a bit of experience on working with eCognition, and I think that will play to our favor here in terms of answering any questions that you may have during the webinar. If you do have questions, feel free to enter those into the question dialog at any time, and we will answer these throughout the webinar. We will also provide some question and answer time after we complete the presentation. So again, feel free to submit a question anytime, and we will look into these. First of all, for those of you that might be new to eCognition, just an general introduction to the software itself. The software is for using geospatial applications, and we're going to be working with eCognition Developer today. This is a development platform to automate the interpretation of geospatial data. So taking our representations of the real world, whether that's going to be an optical image combined maybe with elevation data, whether that's point clouds or a raster format of elevation data, combining those into a single project environment and extracting meaningful information from these geodata sets, whether that's going to be a land cover map, an impervious surface map, or even identifying individual plants, trees, in fields or whatnot. That is all possible within eCognition. Today we're actually going to be looking for flooded areas in the hurricane area. And what we use is eCognition is based on the concept of object-based image analysis. So just a general introduction to object-based versus, say, maybe pixel-based if someone's coming out of that environment. Here in the slide, we see a representation of an image with the pixels. And really, we're restricted in terms of the information that we can use when working with single pixels. We can, of course, play on the spectral information, but that also limits the way we can interpret an image. Here, we can create 2 classes in this example, land and water, from our image. When we start to look at the use of image objects, though, we now have a great deal more data available to us, attributes, what we call features in eCognition. So here we're grouping like pixels together to create meaningful image objects. This allows us, based on the additional information we have, say it could be simple area on shapes of objects, but more importantly also the context of image objects. How do certain objects relate to their neighboring objects? This allows us to better describe what we are looking at and mimics more our human visual perception. So in this case, we can start splitting up between the mainland and say an island, or rivers and lakes. So if we think about an island, it's simply a landform surrounded by a water object. Or here, river versus lake. Typically, rivers are going to be elongated in their form, whereas lakes are going to be more, say, compact and maybe even larger in their size. So these are conclusions we can make based on image objects that just aren't there when using something like a pixel as a descriptor. And using this type of methodology throughout our analysis allows us to just create an overall, a more accurate representation of our landscape. eCognition, what it's all about is extracting this geospatial information from our input data. Again, that can be in the form of an optical image, whether it's coming from a satellite or an aerial flight or UAV data, and also to update certain cadastral data sets with new information that could be coming from new imagery that's been flown over the past year or so. eCognition suite is composed of several products. Our presentation today involves primarily the developer product, but the concept we are showing is certainly can integrate eCognition server. The developer, like I've already introduced, is a development environment. Here we can create our analysis in this type. This is where we created our image analysis approach for fast prototyping, what we call the rule set. But we can also apply these rule sets within developer. Where server comes in is this gives us the production environment for those rule sets that we create within developer. Here we can do the batch processing and start to go into full production on that rule set. So in this case that we're going to look at today, we started out looking at a single image, but we can then apply this to multiple images that would cover, say, the entire study area or the entire area impacted by such a widespread event as a hurricane. So natural disaster mapping or monitoring within eCognition, that's one of our topics here today. In general, there are certain minimum requirements that we should consider when reacting to such an event. First of all, normally there's a fast response time. We need to get the information processed very quickly for the people on the ground and the decision makers to analyze the situation and draw conclusions. We also need flexible area coverage. These events don't always occur in the same spot. They are oftentimes relatively unpredictable. So in this case, a satellite imagery is ideal. We have that coverage around the clock, around the globe, and also gives us a wide coverage area. In addition, high temporal resolution. So how often are we getting the data, and to provide timely updates. So the more frequently we get data, the better it is for such situations, because we can update the information that we're sending out to people making decisions. And finally, high to very high spatial resolution is always good, depending on what level of detail we need to provide the information in. So the more detail we have, the finer resolution we have, the more we can see within the image and go from, say, a large flooded area to identifying individual flooded homes and things of this nature. In addition, other input data that is nice to have for natural disaster mapping, well, a pre-disaster image. Oftentimes what we're doing is comparing a pre-disaster circumstances to something that's going on during the disaster itself, or to post-disaster situations, whether it's going to be in imagery or in some other form. So it could be comparing the image, a pre-disaster image to a post-disaster image. We could also be comparing the post-disaster situation to cadastral information that was collected pre-disaster. So for example, building footprints, roads, things of that nature in a shapefile. Elevation data, it's always nice to have if available. This allows us to draw various conclusions, calculate a number of things, the depth of flooding, for example, and find houses in a more transferable manner within eCognition. But again, optional, nice to have if it's available. Typically, image analysis approaches to mapping and monitoring of natural disaster, we call this change detection. So again, a comparison of that pre and post disaster condition. In remote sensing, or at least in remote sensing within eCognition, there are three general approaches that can be taken here. What we call image-to-image change detection, where we really compare image situation in what we call T1, so the first time period, or to T2, which could be the post-disaster image, or multiple time steps throughout that period. We can also do image to a cadastral change detection, so comparing, say, that post-disaster image to the cadastral information, that GIS layers of the pre-existing conditions. We can do that also within eCognition. Or what I call here classification to classification, doing a simple classification at T1 and T2, and then comparing those differences directly within eCognition. Three different approaches to a problem, and all three will yield interesting and useful results in the end. So this is where I'm going to hand over to Matthias. He was the technician that looked at the Hurricane Harvey example, and please bear with us one moment as I hand the microphone over to him.
So hello everyone. Now it's me, Matthias, speaking. I'm the technical support engineer for eCognition, and I'm going to walk you through the use case of the Hurricane Harvey mapping that we did. And first of all, a short recap of the event. So Harvey actually formed on August 17th. It made landfall on August 25 in southern Texas in the US. And it dissipated in September the 3rd. And actually on the map on the right side, you see the Harvey's path in the black line. So it hit the coast at Rockport, and then it turned to northeast. And overall, the damage was estimated to be more than $70 billion for Hurricane Harvey. And another interesting fact is that you can see in the map on the right-hand side the rainfall that came along with Harvey. So in the black color is actually indicates more than 30 inches of rainfall during 5 days. So it's between Friday and Tuesday. And you see for Houston, you actually have 43 inches of rainfall within 5 days. And this is actually almost the whole rainfall of a normal year for Houston. So what we see, we had significant and widespread rainfall, which led to severe floodings. And now the question is, what type of information is needed? One is the extent of flooding. Second one could be number of buildings and home affected, or the infrastructure that is affected. Based on this, we developed our objectives for our analysis. So we wanted to automatically extract flooded areas after Hurricane Harvey using optical satellite data to determine first the extent of flooding, then flooded roads. Then we wanted to create a heat map for flooded areas based on county level. And finally, a heat map for flooded areas based on a grid. So the project area is actually indicated in the map with the red bounding box. This is actually the coverage of one Sentinel-2 tile, which we just took as our study area, and it covers 10,000 square kilometers, so it's 100 times 100 kilometers. And this is exactly in that region where we had these floodings and these massive rainfalls southwest of Houston in Texas. The data. So we were using Sentinel-2 data. This is a data set from the European Space Agency. It's an optical satellite, it's actually 2 satellites, and they have 13 bands, so it's multispectral. The temporal resolution is 5 days, so each 5 days you get a new image of your area, and the spatial resolution is 10 to 60 meters. And on the image at the bottom, you actually see that it's very comparable to the Landsat data sets that you get. We also have bands in the shortwave infrared and also the optical. Sentinel-2 doesn't have the thermal bands, but it has more bands in the red edge area and also 2 in the near infrared. For our analysis, we actually use bands 2, 3, 4, and 8 of Sentinel-2. These are the 10-meter bands and correspond to blue, green, red, and near infrared. Okay, so the input data that we use for our use case, we took 2 acquisition dates with these 4 bands, so blue, green, red, and near infrared, which have 10-meter spatial resolution. And we took one before the flooding and one afterwards, that you see on the right-hand side. Additionally, we added 2 vector layers, one road layer. We couldn't find a good layer for building footprints. That's why we chose to go for the roads. And we took a county layer. All right, and now I'm going to show you in eCognition Developer how we derive the products, the flooding products. This is how eCognition Developer looks like, and I actually loaded all the data into one project. Here you see time step 1, so the acquisition before the floodings, and if I swipe here, you see it during the floodings. So these were the 2 data sets, the raster data sets. Then we also have the counties. These are depicted here. So this is the shapefile depicting the different counties. And we also have the roads layer. So these are the roads we downloaded from OpenStreetMap. All right. Now I'm going to show you step by step our analysis, our rule set, and therefore I'm going to go, I created a small subset of the area so we can actually execute it fastly, so you actually see right away what happens. Okay. So I'm going to go through actually this our rule set here on the top right, which is in the process tree, and these are actually the different processes that are using different algorithms, and I'm going to go through these and explain what happens. So now you see we have a small subset. It's again up here, we have time step 1 in the upper pane, and down here, time step 2 during the flooding. And I'm just going to zoom in quickly so you see the spatial resolution of 10 meters. You can see single houses and also almost single trees. Right. So first thing that I did was calculating the NDWI, which stands for Normalized Difference Water Index, and it's calculated via using the green layer and the near infrared layer. So the formula is green minus near infrared divided by green plus near infrared. And this layer is very helpful to classify flooded areas or water. And the algorithm that we are using is called layer arithmetics, and it's more or less like a raster calculator. You can do any calculations with your raster data sets and calculate new raster layers within eCognition. I'm going to execute this. This number depicts how long it took to calculate execute this this function. And now I'm going to show you for the first time step how it looks like. So it's a grayscale layer. High value, high positive values correspond to water, so the bright areas, and low values correspond to non-water. And for the second time step, it looks like this. So you see flooded areas are now have bright colors, which indicates that it's water. Okay, let's get back to the original view of time step 1. I'm gonna close this box here, open the next one, which is called segmentation. This is actually what Keith talked about, using objects. We use segmentation algorithms to create objects, and in this case I used a multi-resolution segmentation approach, and I'm creating fairly small objects because I wanted to also get small flooded areas. If I execute this, you see we've generated objects. I'm going to zoom in a little bit and can highlight them. And what's also interesting now, what is here in the image object information window, now you have information about the spectral reflectance of each object, but also other features that Keith mentioned, such as geometry. So we have here the area of the object and also the shape. In this case, it's a very elongated object which belongs to a river, and we can check the density. It's below 1 because it's not very dense. And if we choose another object here, this is not that lengthy and therefore also has a higher density. And this can be used for classification to discriminate, for example, as Keith mentioned, a river object from a lake object. All right, after segmentation, we're gonna classify these objects. And I have here, I divided into classification time step 1 and time step 2. And I'm simply assigning classes to the objects based on a threshold of the NDWI, so the normalized difference water index. It's a very simple approach, but it works very well. And if I execute this part, I actually see two different colors. This beige tone is classified as no open water, and blue is classified as open water in time step 1. If I now execute the same for time step 2, we see these bright blue areas pop up. These are actually the flooded areas. I call the class flooded areas. And now we have a classification for time step 1, the water areas, and time step 2, which then is the additional area that's covered by water, which are classified as flooded areas. And now we are almost at reach our first product, which is the flooded area and extend. But first, we're going to do a refinement, which is merging objects and apply a minimum mapping unit. And I'm going to show you why. So we still have a lot of objects, even though they belong to the same class. This is why we merge them together. It's something like a dissolve option. And then we're going to remove really small objects that are smaller than the minimum mapping unit. And if I execute this, you're going to see the number of objects is decreasing, and we have larger objects now. And this now can be exported as shapefile and can be used for further analysis. You also see here in the image object information window at the bottom flooded area. So this is the flooded area within this small subset. So it's 67 square kilometers in total. Okay, so this was the first product that we created. Now we're going to look at the roads, and I've showed you that we've used actually, or we loaded also the shapefile of the road network into eCognition, And here in this first step, I'm going to segment again and use this shapefile to create my objects. And now you see the road network in here. It generated lengthy objects. Next step I did is I classified these objects that are covered, these road objects that are covered by flooded areas. I classified them into a class, in a temporary class called flooded roads.
Matthias, we just have a question here regarding the processing and the procedure used for processing. The question is, will this work on any format image? By that, I take it you mean whether it's going to work on an image that's in TIFF or JPEG, or maybe you also mean will work on, say, Landsat imagery as well as the Sentinel data or some type of aerial data. And Matthias, I'll let you answer that one.
Yeah, so we actually support a lot of different formats, TIFF, JPEG, IMG, and also all satellite data. So it doesn't, the resolution, the spatial resolution doesn't play a role. So you can load Landsat data also together with high resolution UAV data. So this isn't a problem in eCognition.
I think one thing that we should point out when calculating something like an NDWI, that only requires that the imagery that's being used will have the bands required to calculate the NDWI. So it's the near infrared and the green.
Right. Perfect. So I'm going to keep on showing you how we classify the roads. So now we classify the objects that are the road objects that were classified as flooded areas are now classified as flooded roads. It's a temporary class. Then in this process, I'm actually vectorizing them. So I'm going to create a vector layer out of this out of these road features that are flooded. And then I'm going to classify the temp flooded roads class or the temporary class back to flooded areas. And if we check now the road layer, so this is how it looked like at the beginning, and now we actually extracted the flooded roads, which are highlighted here in red. And this can be very helpful information actually for the management on the ground. If you want to get from A to B by your car, this might be a very helpful information. Okay, so now we have showed you two products already. Now we're going to come to the third one, which is calculating the percentage of flooded area per district. And here we're actually calculating, creating a new level above level 1. So we're creating level 2, and then we do another segmentation, which then cuts out the county shapefile. And then based on these large objects, we're calculating the percentage of area that is flooded within that object.
I may just jump in again. We have another interesting question here regarding the chessboard segmentation and why we have that large number there, 1 million or 1 billion in this heading. This is defining the size of our chessboard. So we want to cut out a shapefile and convert that shapefile to image objects. We're doing this so that we can create essentially two image objects. Let's say one would represent where the shapefile overlaps our image. The other would be the area that doesn't overlap our image. So this is one technique where we essentially apply a large cookie cutter to the image and cut out those shapefiles and convert them to image objects here. So that's why in this case we're using a very large scale parameter. We don't want to break, or excuse me, a very large chessboard size. We don't want to break it down into many little chessboards with the outline of the shapefile. We would like our shapefiles to stay as they are, one single shapefile, a polygon within this, and then that is the reasoning for using such a large scale parameter, a large chessboard size in this algorithm.
Thank you, Keith. That was quite a good explanation. I'm going to continue here. So, we have this large number here to cut out the objects of the shapefile, And then in this section here, we just classify these objects based on the percentage of flooded area. And the classes are actually down here. So I decided to set these boundaries 0 to 5, 5 to 10%. You can define them yourselves. It's just how you want it. And when I calculate this, you're going to see in this case, you're going to see it better in the big when I show the whole scene, that this county down here has 10 to 20% of flooded area. This one here, 30 to 50%. On here on the left, it's more than 70%.
Another question came in regarding whether we were contacted or doing this work in cooperation with someone from Texas or any of the states affected by Hurricane Harvey. No, we were not. We were doing this purely as what we call fast prototyping or proof of concept. We wanted to demonstrate that, first of all, it is possible to do this type of analysis in eCognition. It's possible to do this with Sentinel data, which is an excellent free data source to allow any eCognition user to quickly and cost-effectively create such an analysis. You can download the data for free and quickly create a rule set to do this type of an analysis and then provide such helpful data to the boots on the ground. In this case, we were doing this just at the tail end of the hurricane event. But if anybody is in the midst of a natural disaster and would love to contact us and looking for help, please do so. We'd be more than willing to work with you and assist you in such an event.
All right, I'm going to continue. We already generated now 3 products, and I'm going to go to the last one, which is more or less calculating, creating a heat map. So it's the same procedure as for the districts. In this case, we're using a smaller value here for the chessboard. So we're creating a chessboard and assigning percentage of flooded area to each chessboard object. So if I execute this, you're going to see you get this heat map looking like visualization, and the red, dark red colors correspond to high degree of flooded area underneath that chessboard element. It's 30 to 50, and in the white one it's 0. Okay, this is actually in the subset I developed this rule set. Now afterwards I applied it to the whole scene. Therefore I'm just going to go and show you the results on the whole scene. Here we go, just gonna set a few settings right. So this is the whole scene, 100 times 100 kilometers. Again, you have your time step 1, and if I swipe, it's time step 2. And first one is the flooded area, the product that we calculate for the whole area. So this worked very, very good. And now we have down here the image object information, also the information of the total flooded area for this tile. So it's 658 square kilometers, which corresponds to 6.6% of the whole area of the tile. Then we're gonna look at the roads. So this was initially the network that we used for this analysis, and then we extracted the flooded roads. They're now indicated in red. So this was the second product. Zoom out again. Then we have this density per county. It makes more sense now, I guess, instead of the small subset. So you see here for each county the percentage of flooded area within the county. In this case, it's fairly severe. It's more than 70%. And then finally, we have this heat map looking like result that corresponds to the flooded areas. Okay, so that was it for the demonstration. A short summary. So we had different input data sets. We had shapefiles and raster data sets, and we fused them together in eCognition. We developed a rule set in a small subset and then applied it to the whole scene and generated 4 different outputs. One was the flooded area extent, then the affected roads was the second one, third one was the percentage of flooded area per county, and then the last one, this heat map looking like result. Okay, so I'm gonna hand over to Keith again. He's gonna do the wrap up, and yeah, I think I'm gonna help you answer a few questions in the Q&A that we have afterwards.
Okay, everybody. Hope you found Matthias's presentation interesting and what his techniques were understandable. Again, this was something we did not do in association with any of the organizations within Texas. We were doing this completely on our own. Wanted to prove whether this is possible. First of all, with some of the new Sentinel data, which is free, and demonstrate how quickly and simple a rule set can be for this particular situation. So in terms of the eCognition software and current availability, we've been getting some information or questions via our support network over the past week. When is, for instance, a new version coming out? Well, we are working on one. Version 9.3 will release very soon. We announced it at Intergeo 2017 in Berlin. And the release date is going to be here in November, again, very soon. I promise you that. And anybody with a valid maintenance contract, of course, will be able to access this version. And it includes some very nice tools, which we will be presenting in our next webinar in actually post-release, just after the release in December. So, and this is a good segue into our resources here. So we have some upcoming events. Again, our next Geospatial webinar will be on, excuse me, that should be December 12th, sorry, or excuse me, December 13th. Sorry about the confusion on that. And this webinar will be What's New in eCognition version 9.3. I will present some of the new features and tools available in 9.3. Some very great work has been done by our engineering team over the last year to add more value and capabilities to version 9.3. And we will present those to you then. In addition, we have some eCognition training events coming up. So for those of you that want to venture down to Melbourne, Australia, you are more than welcome to join us November 13th to 16th. We're having an open training event in Melbourne. If you're interested in that, then you can certainly contact Matthias or myself after this webinar, and we can give you the details. It's a little short notice. I am actually flying out tomorrow to go down to Australia for this event. It's going to be a developer fundamentals training as well as an analysis strategies workshop. In addition, we have a tentative event planned for May 15th to the 17th, 2018 in Berkeley, California. And this will be a developer fundamentals training. We are still finalizing those dates, but those look pretty good at the moment. We will, of course, once everything is finalized, announce this on our website and within the Trimble Learning website, where you can register for these courses. Additional eCognition resources, you are always welcome to subscribe or read our eCognition news. Typically like to bring this out on a monthly basis. It's done via LinkedIn, and we present interesting customer stories or some of the fast prototyping that we have been doing here internally. For example, you will find an article about the Hurricane Harvey mapping that we did if you need to get more information about what you saw here in the webinar. I should mention too, for those of you that maybe had to sign out early from the webinar, this webinar is being recorded. It will be available on the Trimble website after we conclude. You can also, if you're interested in the eCognition software, I hope we were able to spark interest for some people, you can download the free trial at ecognition.com and then experiment with that. In addition, we have our eCognition community, over 14,000 users there, where you can take part in various discussions, post questions, download guided tours, and even rule sets. And one thing we will do after we conclude the webinar is we'll make this rule set available within the eCognition community so that you can test this on your own data and use some of the concepts that you saw here and hopefully get some useful maps out of that. So this concludes at least our presentation. I'd like to take a few moments to go in and look at some of the questions that we have received here while things are going on. I know there was one question, Matthias, regarding the scale parameter that you use for multi-resolution segmentation in your analysis. So I'm going to hand the microphone back over to Matthias, and I will join you in just a few moments.
Yeah, so the scale parameter, what I tried to say during my presentation is that I chose a fairly small scale parameter to generate small objects. And the reason for this was that I also wanted to capture small flooded areas. You could also go for a larger scale parameter. It would result in larger objects, but then you would miss out probably smaller areas that are flooded. And I hope that answers the question.
I think so. There's another question here. Please share the user guide for eCognition. The user guide is actually installed with every version of the eCognition software. So if you have your developer there, you can just simply go into the help menu within eCognition developer, and you can open up the user guide directly from developer. Going down the list again, yes, someone asked again, will this rule set be available within the community? Yes, we will make this available in the eCognition community. So again, if you would like to download it and use it, you're more than welcome to do that. That was actually from Niels. Hi, Niels in Norway. And those are the only questions that have come in so far. If anybody else has a question, you can certainly post it in the question dialogue, or if you want to contact us afterwards, you do see our email addresses here in the presentation. So Keith_Peterson@trimble.com and Matthias_Stengel, that's with an AE. NGL@trimble.com, and of course there is also support at ecognition.com where you can reach one of our support technicians at any time, and we'd be more than willing to answer your questions via those channels as well. So if there are no more questions coming in, I'll be happy to conclude the webinar. Again, it is being recorded and will be made available on the Geospatial webinar site that you can review this material anytime you like. So thank you very much for attending, everybody, and I hope you enjoyed this session, and stay tuned for future webinars coming up. Again, we have one coming up on December 13th. That will be the introduction to eCognition 9.3, and hope to see you there. Thank you. Bye.